Hey everyone. So what we're going to be focused on right now is I'm going to go ahead and go to that. Is today we talked about mass number and finding the mass number. Before we get going, I want to make sure that we explain that if we have three subatomic particles, that is known. Well, there's more, but I'm not. That's pretty high level stuff. And so first and foremost, we have protons, neutrons, and electrons. Protons and neutrons live in the nucleus, where the electrons live in the electron cloud. Protons and electrons have a charge. Protons and neutrons have masses. Okay, so electrons don't have a mass. Beforehand, we talked about that the atomic number is the number of protons. And if they're a neutrally charged atom, meaning they don't have a charge, we have the same amount of protons as we do electrons. And that's not the case in the real world, and we don't want it to be the case because we haven't talked about electrons and electron charges. Okay, so we're going to come back to that, but for right now, we have protons equal electrons. Okay, but we're going to talk about things that have a kind of a different type of a nucleus. Not all atoms are made equally. Some are more abundant, some are not. And so we're going to be focused on isotopes. Okay, so iso means different. An isomer is a different shape. Isometric, so a different category. Okay, iso means different. Tope means type. So this is a different type of atom. Okay. All right, so go ahead and get your notes out. Your notes will look like that. Okay. So, all right. So, what a isotope is an atom with a number of with the of the atom element. Excuse me. I need to rephrase that. Atoms of an element. You might have to change that on your screen, on your thing, with different number of neutrons. Okay, so remember, protons make the atom. So oxygen is oxygen because it has 8 protons. We have carbon is carbon because there's 6 protons. Nitrogen is nitrogen because there's 7 protons. Think mercury is 80. I don't know. So that's what makes mercury mercury. And I'm going to go ahead and go back so I can explain to you what isotopes are. So isotopes are significant because they lead into one thing is radioactive stuff. We have to explain that later on. And they also lead into naturally occurring atoms. Now, isotopes can be made in the lab. It's very difficult, but naturally they do occur. They lead into the carbon that is in the air, the nitrogen in our air as well. It also leads into radioactive medicine. So when you're doing when you're doing radiation for medicine. A new big thing in the true crime era is isotopic research. So isotopes can actually determine where you were spent your early childhood at and where you are currently living by looking at the isotopes within the soil. That would lead basically because we get everything from the ground up. So the soil in our soil can lead into what our hair isotope research is, but when we're baby, we have our molars and our femur, which is the big leg bone, that could lead into defining of where we were raised at, a good chunk of it, okay? All right? So there's a lot of implications, and then the other big thing is nuclear energy, which is a very, very important amount or where we get 20% of our energy here in Kansas, no matter what. Okay. And I do believe that there's going to be more of that coming up. Okay. So what is an isotope? An isotope is an element with a different number of neutrons. So remember, oxygen is oxygen. And also to let you guys know, I'm going to break into this and go to a drawing too. So I'll pause it here in a little bit so that I can open up Google Drawing. The number of isotopes, the name of the isotope is the name represented by the dash, and the atomic mass of the isotope, the mass number of the isotope. And we're going to get into that. An example, carbon can have 6, 7, or 8 neutrons. So carbon with 6 neutrons is carbon 12. Carbon with 7 neutrons is carbon 13. Carbon with 8 neutrons is carbon 14. So you really have to go back and do that mass worksheet that you guys had. Okay? All right, because you can't figure this out if you don't have that. Okay? I'm going to pause it. Okay, so this is the Google drawing. This is represented like right here at the bottom, and we're just going to go through that. I'm going to work with you on this. So it does not look like yours because I'm going to go through each of these steps. So these are all hydrogen, but we got to figure out what hydrogen they are and how they take place. So if you notice that I have one red dot there in the middle, I'm going to say that that red dot, I'm going to go ahead and copy it, is going to be, and I usually have you guys get crayons and we do this together so you can kind of see. So we have one red dot, and that is the number of, and I'm going to go insert this. This is the number of protons. So we're going to have one proton. And that's always the case because it's hydrogen, the most abundant element in the universe. Okay? All right. So this is going to still be hydrogen. So I'm going to go ahead and copy. And so each of these little dots, and if you could go and pause this if you need to get crayons and just do the same. It really helps. It is not beneath you. It really helps to visualize this, to have a color coding visualization. So each of those is one proton. Okay? All right, because it is hydrogen. So I can even write that on the top, just like what we have here. This would be hydrogen. Copy, and I could just put it here and paste it. And paste it. There you go. Okay. All right. So this is, there we go. So each of these, like I said, is going to have one proton. Excuse me. Copy. So I'll pause it just for a second. Okay. So there's that. So if you guys notice that, go ahead and pause me, and then you guys can write that down. Okay, so this first one, if you notice here, is hydrogen 1. And we're going to explain where does this come into it. Hydrogen 1. This is hydrogen 2. And this is hydrogen 3. Okay. All right. Where did we find all of that? Well, 1 is always on the periodic table. That's that whole number. Okay. So we're going to determine the next part is why does this change? Okay, so like I showed you guys, told you guys this is a neutral atom, so we're going to have the same amount of protons as we do electrons. I'm going to pause this and get that next part up. So if you notice that I got that up, and I have one electron, and why is that? Because if you look at the very top, it says examples, neutral atom. Okay, so the electron, remember, is 1/2000th the mass of the proton and neutron. So they don't matter about mass, but they're the reason we have life. straight up. Okay, so this is the reason why we have compounds and why we have the ability to conduct and have life here on Earth and the universe. Okay, all right, so but if you notice that this is hydrogen 1, 2, and 3, so what we need to do is figure out how that is. Well, remember we have protons and electrons. We have a third guy named neutrons. And I'm going to go ahead and make neutrons blue, a deeper blue, because they are neutral. All right, they don't have any specific color. They're just, this is a representation, that's why it's important. And so the top part of our assignment, you're going to have to do that. All right, so if we have 1, we actually have 0 neutrons on this, because 1 plus what equals 1? Well, that would be none. Okay. All right. The next one we got to get to 2. So 2 minus 1 equals 1. Now, this is the only time that you'll have no neutrons, and that's what makes hydrogen very unique but very essential. And then we have 3 minus 1 equals 2. Do you guys see that? So 2 plus 1 equals 3. And so in here, we're going to have one neutron right here. And we're going to have 2 neutrons. And we're going to later on talk about how abundant is their hydrogen how many hydrogen 3s are there? How many hydrogen 2s are there, and how many hydrogen 1s, and how is that significant and why we want that? Okay. But this is basically what you're going to be doing on your assignment. I'm going to pause this so you guys can see. Okay, so this is what we're going to be working on. This is the assignment. It's a paper copy, so I'm going to have it downloaded in Google Classroom. I also am going to have it in a paper copy, and I recommend you need to do a paper copy. So here's the isotope name. I know it's cut off a little bit, but we have potassium-37. I would wait on the top portion tomorrow, because we've got the symbols and I wasn't able to go through it. I've only got a couple more minutes in this video, so I'm going to go quickly. So we have boron. So each of these, so you're going to kind of have like either make a different color dot, so it'd be like reds or protons. You're going to look on the periodic table. How many protons does boron have? You're going to make either plus signs or you're going to make dots. How many, and it should be the same right now for electrons, but make those either a negative or a different color dot. Okay, and you should have the same amount of protons as you do electrons. Okay, now what's going to be different is the amount of neutrons on this, and it's going to tell us here. So we've got to have what's in the nucleus, the pluses minus the negatives should be the pluses plus the neutrals should be the number that goes here. There's a certain amount of boron always has, and so all that pluses should be the same here. Here is the isotope symbol. Hold off on that. We have the atomic number, the mass number. Right now we learned that it's 37. Number of protons, find that on the periodic table, should equal the number of electrons, and then you're going to have to subtract. But we're going to find something out that's very similar for boron down below, and that's why why I do this assignment, is because you start figuring out that, hey, something's a little weird, and there's different types of elements, hence isotopes. Okay, but we need to figure out how to define isotopes. We need to figure out how to symbolize them, and we needed to figure out how to write their names correctly for that given isotope. We'll see you later. Have a good one.